And where was that slideshow presenter view?
Start.
Oh,
Oh. Um,
does that work?
no, yes, it has.
Okay, cool.
All right. I think everyone's here. 12:23. We'll wait a few minutes to let any. I think this is everyone really. Is everyone? Okay, cool. All right. Hi, everyone. Welcome to today's presentation on T3 Alliance program. So, for any of you who are interested in STEM education, which includes things like mathematics, engineering, and science, T3 is a program that gives you these opportunities to develop these skills, as well as other communication and collaboration skills that will help you work as an effective team in any sort of engineering project. My name is Daryl Albano. I recently graduated from the University of Hawaii at Hilo with a degree in computer science. I was also a former upper bound program, so I used to be part of the math and science program here at the UB program, so I have a lot of experience or background in that case. And then I went on to pursue my aforementioned degree in computer science. From there, I did a lot of robotics, internships, and things from Mauna Kea telescopes all the way to NASA Ames Research Center. And yeah, we're going to discuss about T3, go into detail about what you will be learning in T3, as well as your expectations as a T3 student. It's going to be an awesome experience. We're live streaming, right? All right, cool. Next slide. So T3's main focus overall is STEM education. Now, as stated previously, STEM is an acronym for science, technology, engineering, and mathematics. Here in Hawaii, there has been a large growth in STEM education for the past 20 years with our developments in robotics, funding availability from organizations such as the National Science Foundation, the 30-meter telescope. These have allowed high school students to participate in major STEM programs nationwide. And we'll be going into detail about that. Next slide. So, T3 Alliance is a group of upward bound programs nationwide working together to help students find STEM opportunities in their community. So think about it like this. Nationwide, we have about 36 other programs which have students just like you. First generation college students looking to find opportunities in engineering and mathematics. What this program does is that it gives you opportunities to do computer programming, robotics, 3D printing, things like that. Next slide. So, as a student in the T3 Alliance program, you are involved in a rigorous and engaging 3-year program. From here, you will develop the initial skills in technology as well as communication. Following that, you will get your involvement in more of a community-based project where you will meet someone in the professional community to work with. These mentors range from your typical agricultural farmers all the way to an engineer at one of the Mauna Kea observatories. Next slide. So basically, as stated previously, we as a T3 program give you the skills, give you the ability to develop this knowledge and these technologies in order to work on these real-world engineering problems. And as stated previously, with Hawaii and its involvement in STEM education, there has been a wide growth and involvement in major engineering fields from agriculture-related fields, as well as astronomy playing a major role. Recently, with the Event Horizon Telescope, Hawaii has played a major role in mapping out the first ever image of a black hole. That just comes to show the contribution Hawaii has to the astronomy field. And now what we're going to do is hopefully, just in time, hopefully we are going to contact our fellow program cousin, I guess you could say, at the Maui Upper Bound program. Hopefully they're still alive. So, as stated previously, T3 Alliance is a nationwide program. Here in Hawaii, we have 2 major institutions that are involved participating in T3. That would be, in this case, Maui. We're just hoping on whether or not they'll join the call. Haven't really heard back from them. If not, we will unfortunately skip that. Any word from Adam?
I'm sending him another invite.
Sounds good.
there anything else you wanted to say about?
In this case, we'll go ahead and skip the Hangouts call for now and continue that later down the line. So continue the presentation.
Okay. Let me see here.
Oh,
Other one, yeah.
PowerPoint, yeah.
Okay.
You can, yeah. Present. Yeah, perfect.
Yep. Cool.
All right, next slide. So here are images of our fellow colleagues. The top image on the right are instructors from other university campuses. They've flown down here to the Big Island to participate in instructor training. These instructors are examples of people who will be teaching you about engineering and mathematics, programming, technology. So yeah, and as you can see, we have several students from last year participating in the program where they're involved in community-based projects and learning how to program on a Raspberry Pi computer. Now, for those of you who aren't familiar with the Raspberry Pi computer, it's basically an inexpensive module, an inexpensive device that allows you to start programming on day one. And the importance of programming in today's field can range from simple websites all the way to large-scale engineering projects. So the wide variety of capabilities this computer has is quite a lot. The sky's the limit in this case. Next slide. So now I will go into detail about exactly what you will be learning in T3. What are the skills you will develop as being a part of the program? Next slide. So starting off, we'll be talking about the technology skills that we'll be learning. So as stated previously, you will be learning about computer programming and 3D printing. These technologies were introduced last year as sort of a year one incentive and early curriculum for the students to learn. So alongside that, you'll be learning how autonomous systems work. This would be things such as unmanned aerial systems or drones. If you're familiar with DJI drones and things like that, basically drone footage, or if you watch a YouTube video with aerial footage, that's sort of the concepts that we will be tackling. Specifically, how do we engineer these drones, how do we develop them, how do we operate these drones? Next slide. Above all else, the most important thing to develop are your project management skills. Now that sounds really, really boring actually, talking about project management. It's like, oh gosh, we're gonna talk about budgeting, project scheduling, things like that. Initially, you're gonna have that feeling of like, this is a lot of busy work. Next slide. However, the most important part you can pull from these activities is that you're building team building skills, which are very essential when you're working on an engineering project with either a mentor, a community member, a client, etc. And when it comes to managing resources, the truth is time and money are very limited. And when it comes to working on these projects, having a better sense of management with these resources can help you better achieve your goal, come up with solutions for these problems in our community, these engineering problems, above all else. Next slide. And third but not least, we have our communication skills. So throughout the curriculum, you'll be giving presentations, editing videos, and presenting these work to clients and working with them. And the most important part about these communication skills is that when you're working with someone, you want to make sure that you have a self-initiative to learn what information is needed from them, as well as presenting the work to other students so that they're able to understand what work you've done during the summer and throughout the academic year. These are some of the most important parts that comes into being a T3 student. Here are some images from our work from last year. We have some students working on the Raspberry Pi computer. In fact, the image on the right, top right, that is one of our, this is going to get too technical, but that's one of our modules that allows us to do a lot of things. So imagine you want to know what the temperature is and how humid it is. This sensor allows data collection of that, so you can identify whether it's too hot, it's too cold, or it's too humid, not too humid. It's a very useful tool, especially since it's not that expensive to develop. And on top of that, you'll be learning how to program it, and that's the most important part, is just working and tinkering with these devices. We have, we have additional images of the students working on their Raspberry Pi boxes. So here's an example of some of the tech that they've worked with. So this guy is a computer. I know it's made of wood, but there's a computer inside it. And the way it works is that it has a monitor, it has everything you need to get started in electronics and programming, all in a convenient and portable box. Yeah, that's basically it. And that's one thing that we really strive for in T3 is to make things accessible, make things easy for the students to understand. So basically, for example, you could have this box, take it around with you, and if you want to learn how to wire up an LED or wire up a button, you can just do that on the spot with the Raspberry Pi box. I tried to make that rhyme, but we're going to proceed with that. All right, next slide. All right, so as stated previously, the expectations as a T3 student involve three main criteria. Next slide. The first point is to have a sense of initiative, a sense of self-directed learning. In this case, having an initiative for your own learning involves not relying on other people to get knowledge, but rather having a self-drive to pursue unknown topics, challenge yourself, and find new things that you haven't learned yet. Although learning something new can be intimidating, like let's say in your math class you're learning about a topic that you're really unfamiliar with, having that drive is an essential trait for becoming a T3 student. Next slide. On top of that, I want to get into the topic of growth mindset. So how many of you in this audience have had experiences of self-doubt or feelings that this topic is really, really difficult and I can't really understand why it's too hard? How many of you are ready? So basically having experiences where it's like, oh my gosh, this topic is really hard. Like let's say Algebra 1, for example. You're learning about Algebra 1 and suddenly you're like lost and confused and it's like, oh no. Yeah. So those types of feelings, that thinking mindset is something that we aim to target on, or in this case, improve upon when it comes to the T3 program. So when it comes to any sort of engineering project, it's always going to be a very difficult endeavor. You're going to have projects where it seems out of your league. You're going to have you're going to learn new technologies that seem really, really difficult. But with this program, we aim to get your mindset thinking that this topic, this technology, this project, although it may seem difficult, the things that I'm learning from it, the failures in this case, will improve my learning in the long run. For example, when I was a student at the university, I faced a project where we developed a planetary rover. This rover, its ideal purpose was to navigate Mars and collect regolith, which is a form of material you find on Martian terrain. This type of project was way out of my league, mainly because I didn't really have an engineering background. Most of my background was in software. So on year one, I had to learn things like computer-aided design, where I'm 3D printing and modeling things in real time and things like that. And on top of that, learning about electrical wiring, as well as how the motors work and the basic kinematics of vehicles and things like that. And overall, what I pulled from it is that although it did feel like a failed endeavor, over time, it became gradually easy because I started to understand the process and developing these skills. As stated previously, the initiative to learn are traits that are important when it comes to being a T3 student. So basically what I'm trying to say is in year one, you're going to have a huge amount of information given to you. And at first, you're going to have the impression of, this is out of my league. Engineering isn't really my thing. But if you give it time, if you take the effort to learn about it, eventually you'll overcome that thought, that fear, and become a well-spoken engineer. Next slide. And third, but not least, working with the community member. So as stated in the previous slide, you will be developing communication and project management skills. Now when it comes to working with a client, or in this case, a mentor, there are a lot of things to talk about with a mentor, such as what does the project require? What are some things that I can provide in terms of technological abilities to solve and satisfy the requirements for this project? Those are some of the things that the those are some of the important aspects that happen when you're communicating with your community project mentor or any sort of client in this case. Next slide. So here are some of the images from last year's T3 program. They participated, if any of you are familiar, last year there was a huge eruption in Leilani Estates, which resulted in major air quality issues. And so the group last year decided to build these air quality stations that would analyze and assess the quality of air in the Pahoa and Puna regions. So as you can see, they are speaking with specialists in the field that have experience dealing with atmospheric sciences, as well as local professionals who worked with the EPA on developing these or installing and developing these air quality stations. These are just some of the things that we worked on last year, meeting professionals in the field and talking about the sciences involved in developing this project, which later resulted in the group developing their own air quality stations, which they placed at various locations in order to assess the quality of health as well as the danger of the volcanic activity. So now, what I'm going to do is I'm going to hand the presentation off to last year's students who will be presenting their work from last summer. Their names are Christian and Moku. Sorry. Christian Sprinkles and Moku. I'm bad with names, I'm sorry. It's all good. Anyways, probably be me in a game of volleyball anyways. Yeah. Anyways, yeah, these students are alumni from last year. They've been a part of T3. They worked on this air quality project, and they're here to present their findings. We can go ahead and switch the presentation over to the student presentation.
Oh, is it? Oh, okay.
Yeah, just end the show and swap.
Okay.
Cool. Line it off to you guys, and yeah.
So yeah, like you said, the growth mindset and community base. This picture was taken at our first site where they asked us for the air quality, like you said, because of the eruption of the volcano. It was a pretty good summer thing. I know some of you guys. Like when I first found out about this program, I'm more like to do outside. I used to play sports. Never really thought about it until I got more into it. So yeah. Yeah, so we talked to our clients, and this is another place where we went. We had the gym, Pahoa Gym. Yeah, Pahoa Gym. And then so we talked to 3 different main sites to where we can put up our air sensor. So at first, we talked to them, find out the problem, and try to help them come up with ideas for us so it make it easier to solve the project for us so we can get a better base on it. And then just try to solve it all together. So like I said, growth mindset. And then after the summer, after doing all this with the Raspberry Pis and creations and programming that we did, my mind kind of opened up into maybe I should like start taking more into looking in computer science while doing my other things, like my other majors. So this is a video.
I made a lot of videos. But basically, there's 3 main parts in what we did this summer. So there's a hardware, which was like building Raspberry Pi or the sensor. Then there's a software, like what he does, he codes stuff. And then there's a video part, which I was a part of. So basically, we would film like everything we did, and we put it all into one video. So this is one of the videos. I think this is the brush pop video.
There we go.
So if you guys don't know what a brush pond is, it's basically like the end of a toothbrush, and you have a motor and a couple rubber bands and stuff. You put it all together to make it move forward. So during like the academic year, I made mine like really fast. But during this one, I couldn't figure out how to do it at all. So like that's one part of the growth mindset. You figure out and find new ways to do stuff. So like basically when we got given this project, we didn't get like any instruction. We just said, okay, put it together and make it go. And that was pretty much it.
Right.
Oh, I'm just on Hangouts now.
Oh, are they on the Hangout now?
Yeah, it makes sense as to how he's using that.
Okay.
So let's move back to our Hangouts call. Let's see if we so there we go. Turn on that and video. Oh, you just buttons in the center. Yeah, correct. Actually, we might have to turn it around. Oh, okay. Actually, yeah, it's also has the purpose of being a kickstand. We can have just. Yeah, that works out. Hi, so we're basically in a video call with the Maui kids. Yeah, see how it goes. We can actually switch the video back to Adam's view. If you want.
Okay.
Oh, nice. Yeah, hey, how are things going, Adam? I wonder if the audio is actually. Wow, we have like this is like a duality situation. We have two rooms similar. And, yeah. Anyways.
Do you want to get in the camera so say hi now?
Yeah. I don't want to like.
Yeah, yeah.
Wonderful. Hey, how are you? Oh my gosh. Hi.
Yeah.
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 Oh, we got about 5 to 10 minutes. We're finishing up on the student presentations, and then from there, we're just in conclusion. So we can go ahead and do a hello or a little meetup.
Wait, can you hear? Can you hear us? Oh, okay.
Okay, wait. The audio might be coming from. Oh, we're good. Yeah. Cool.
Does everybody know who Adam is?
Yeah, I'm about to introduce him.
Okay.
Hi, Adam. Would you like to introduce yourself to the audience members today? That sounds weird. You might have to re-plug in the headphone jack.
Really?
Yeah, that's weird.
So you want me to unplug it?
Unplug it, plug it.
Okay.
It just sounds about the same.
So we'll be like 15 minutes, but in there on Adam. And we're excited here in the Maui to hear you guys and say hello to you. We have like 7 people to see you. And the people
That's a double.
they're all excited about learning about what you guys have to say and just saying hello. So, I can tell them because we're excited.
Sounds good. Yeah, that'd be lovely. Sounds good.
Oh,
Perfect. All right. Cool. So just a little bit of a notes. Could you mute your mic during more like when we're not calling and stuff like that? Yeah, sounds good.
Thank you.
Yeah, thank you.
All right, cool.
You can
Yeah.
shoot
So
me
we'll
on
do
this.
screen share right now. Your entire screen. So we'll screen share.
So I wonder if that's gonna work. We're both live streaming to YouTube and we're
Yeah.
screen sharing.
Yeah. I think it should work.
Yeah, it's fine.
Okay.
Sorry
All right.
for the interruption, I may proceed.
So in the beginning, when they first gave us our computer, that small thing is the whole computer itself. That's basically it. That's the memory. That's where you plug your mouse, your keyboards, and everything that we did our programming on. At first, they just gave us a computer disassembled. We had to put the box together, then put in the monitors, and then figure everything else out. They basically just told us, "Oh, here, try to put this puzzle together."
Exactly, I like that keyword, puzzle. So it's more of an exercise in this case. But the result is you got a computer at the end, so yay.
Yeah, one of the first things we did is we pretty much hacked Minecraft. So basically, so we built a house by coding, basically. So we built a block and then a house over here, basically. That's pretty much what we did. It was pretty fun. It was a unique experience. And I think this is the video of us putting together the Raspberry Pi boxes.
And hacking into Minecraft.
Yeah.
Oh.
So I guess you could also say that building the computer is like building a Minecraft house.
Sorry.
Yeah, you just said
How do I get out of here? Okay.
I'm guessing right on the D-pad just
Yeah, I did that.
through the video.
Oh gosh. There you
Oh
go.
yeah, that's it. Oh, let's go back and I'll show it. So you can just like 4 fingers up. Yeah.
Okay.
I don't know this.
Yeah.
Yeah. Yeah, no, right? So they're still slowing down. We can still continue.
Yeah, well,
Just
yeah.
continue the presentation, shall we? But
Yeah.
actually, it looks like.
He'll let us know.
Yeah. Cool.
Okay. Oh.
It's actually already in full screen. It's really
Oh, it is. Okay.
That's weird. Yep.
Wait, what? Let me figure
Actually,
out.
what you can do is go back to the presentation. And then click, or just, yeah,
Okay.
click on that.
This one?
Yeah.
Okay. I think it's. Let me. There we go. All right. There we go.
Perfect.
Cool.
All right, we're on it.
So you can see we're right there next to one of the other instructors, in the back next to him. At first, when we started working everything, we started working with LED lights. If you can see, right here. right there, we started working that little white board thing. It's called a breadboard, where we have to plug in the wires to our Raspberry Pi, that small cube thing with the picture that you saw earlier, and then plug it into the breadboard so it can make the LED light turn on, flicker, or a command of a button. And it's all in programming that we did on the Raspberry Pi.
Okay. Hold on. Yeah, I don't know what was. Oh, okay.
And then
Hold on one. Oh, yeah.
oh, it's there we go. Yep. The opposite. Aloha.
Aloha. Yeah, yeah.
All right. Aloha. No. It's
Cool.
after lunch. I guess in other words, sleep is sort of a priority.
Okay.
Yeah. So yeah, let's resume presentation and go from there.
So then now after our next project before the sensors, and then this is after the brush bots, after that we build the computers. Now if you can see on his computer there's a camera, that's a camera with LED lights, and on his screen is the website that we use to program everything from the Raspberry to the camera, and LED lights to take pictures and like use LED light as a flasher or a compact.
Okay, so design thinking is pretty much a big thing for us. We basically go through this with every single project we did. So first we emphasize, we talk to the clients, and we figure out, okay, what do they need, and how we're gonna do it. Then we define, we go into greater detail about basically what we're gonna be building, what we're doing, and stuff like that. Then we come up with ideas, so like the camera thing we were talking about, we're gonna like mount it on a wall, or we're gonna put it on a tripod or something like that. Then we actually go out and build it, we get the materials we need and stuff, and we just test it until it works.
So right here on this paper that they're writing, it's hard to see right now, but it's a grant that we use to write to Mr. Lewis, the director, to see if we can get enough money for these materials for the project that we were doing. We basically wrote like maybe 3 grants at the most last summer.
I believe so. Yes.
3 grants to like 3 different projects.
What was the amount? The big grant amounts?
The grant amounts?
Or like how much money were you
It varied from project to project.
giving? Okay.
So like the Raspberry, the camera sensor, or the camera one we built, probably about 100 maybe. And then I don't know exactly how much for the sensor one. So this is a video of us like putting, okay, so to explain this project, the students here from UHEO, they asked us to go like for the new students coming, a camera sensor so they could like get a feel of what the campus is like and like where everything is. So we put one in front of like the library, one out here in campus center, like we put one like basically everywhere. So
Yeah, it's basically going to be a scavenger hunt during the summer for the summer orientation for the new students.
yeah.
Our team is based at Puerto Rico, and our names are Haiti, AJ, Veronica, and Rihanna. I'm going to give you a common setup for student orientation day. Our plan is to set up the tripod and connect the camera to the RPI during the photo stack event. When you connect the RPI to a computer and code it so that it's programmed to take a picture on demand and the person specs. There is an LED link that will count down with a flash for 10 seconds, which will help you to play yourself with the pictures you take. Our station is located at the campus center, and the camera setup will be on the wall. There will be tape on the foot that will help you with the playing stack. The picture will then be sent to you to new students or organization email. You will react to the pictures taken. That will then be posted on the hashtag of your choice on Twitter or Instagram.
this was our next big project. This one took, I think, like 4 or 3 weeks. This was for the air quality sensors for the people who were affected by the lava flow. So this was like our first step to emphasize with the people there. So one of our teachers, his name is Dom, he made the video for like interviewing people who were actually affected by it, and he showed it to us so we could like get a feel for what's going on.
And this is Cecilia as well.
My name is Dina, by the way.
I had a home in the United States, which I no longer have precedence or anything of, but also am a co-founder at a school for co-connection school.
I live at 13-63 Comet Road, a mile down from the Shore South. I operate the preschool program for Pahoa. Our main campus is down on the Bend Road and has been completely isolated by lava.
Really, my pressing concerns right now is monitoring that quality. So I think that that's pretty still a concern. We have 4 sites, 2 sites in Nilo, preschool in Bolivar, which is very critical, and a hybrid online program in rural.
The prevailing way, which we're training is a prevailing, they're sending the SO2s from right from the fissure kind of down a slope right to our rural subdivision.
So this picture on the right or left, sorry, that was at a site from I think the hospital up here. That man in the button-up shirt, he's like the he works for the Department of Health. So he was like helping us compare data from our sensors with his sensors, and then the man on the right, like the picture on the right, he helped us like do a seismic sensor for like all the earthquakes and stuff that was happening. So it was pretty cool to like meet these people and professionals who work for us in these fields and stuff like that. And then brainstorming. So this is where we were trying to figure out like how we're gonna put all of the sensor components together, and we decided to like get a box, kind of similar to the Raspberry Pi box, but different. Basically, I had to cut a hole into the side of it so the air can flow in, and we can get all the data and it came out to the other side. And this is basically like the layout of it. So on the top right, the big like blue dot thing, that's basically the sensor itself. And then it connects all to the Raspberry Pi. And then on the side, we have like a little LED sensor which could tell us the temperature, humidity, SO2, and all that. And then there's a like how we were gonna put it together inside a box. And this is where we were starting to like put it together. I think Moku's team was in charge of the software. So you might have done about that.
Yeah, the software was like in the beginning. We had to first learn. On the last slide, there's a screen in the top left. That little screen was projecting what the SO2 temperature and humidity was at the time. So we had to first figure out how to work the screen and then try to add in the SO2, the air sensor, all in this one box. And we basically did it. There's 3 groups. He was part of the editing group, and then there's the hardware group that built the box, and then we were using the program to make everything sure everything runs, got everything planned out. So when we put it in the box and set everything up, it's just gonna work straight off the bat.
What I like about that is that you had 3 different groups that specialize in different fields. They had skills and abilities that one had and the other didn't. So they sort of worked collaboratively in a way that benefited the whole team overall.
And then this was us building it. You could see she was drilling a hole into the side of the box. That's for the sensor to collect all the data. And then I think on the top right, that's a grant. Yeah, the grant we put together.
But everybody had their own ideas, so like this one is a different group, so like they probably use more money than like some other groups. It all depends on like what you guys want to build or like who's with your partner or who's in your group, like what you guys want to do. So it would range out to the different model monies in that grant when you guys fill it out.
And then we put together a website for the community to actually look at our data. I'm not sure if this site is still up and running or if it's still collecting data, but during the summer it was, and we could go to the next slide. Oh, I thought the data was on this slide.
This is mine.
Yeah, this is the Department of Health where we're comparing the data. And then we also went to the Pahoa Shelter, where there's like actual people from like seeking refuge from the lava flow. So what we did was we put a screen or like a TV with the website like already put together, running on the screen, so people out at the shelter could just look at the screen and be like, oh, that's so cool, like bad today, or it's good. And then this was at the KL shelter. So this was kind of like a last minute thing, but our van broke down when we were going to the next site. So we just put it like, because we were like right outside the shelter, so like, oh, let's just put it here then. And then Dragon Ice Farm, I think these guys are the closest to the lava flow. So basically like they're like pretty far into Pahoa. So like when we were putting it together, we couldn't like smell it, but they said like a couple of days ago they could. So it was kind of nice to meet these people and like talk to them and like learn their experiences from it. And this is the sensors that was putting out data. As you can see, like the sharp line, like that's going up and down. That's the SO2, and then on the right, that's the temperature. And then we also had humidity up there too, and particulate. And at the end of the summer, we gave a presentation about what we learned. So me personally, I learned a lot. When I first joined T3, I thought it was going to be like just computer science and software and stuff, but I actually did meaningful work. And this was like a video of all the steps we went to put together.
Okay.
Yeah, that's what I said. No, I did this video. So there's like
Nice.
an entire team of us doing these separate videos. And it was kind of cool to see how like even in the hardware and like software stuff, people had their own ideas on how they wanted to do things. Like seeing people's perspective on different stuff, and it's kind of cool. Like some people, like me, I do like fast-paced edits, and some people do like slow, like hit, like tell the story kind of edits. And stuff. You guys have any questions?
Well, let's give it a hand for Mocha and Christian for that lovely presentation.
You want to check in with the? Oh, he left the call.
Okay. So funny story about that. I got a text saying that their audio is pretty bad, so they
Okay.
ended the calls.
Okay.
We just cut that. Fortunately, our Maui brothers are not here with us. So. Oh, do you have a question? Or are you stretching? Yeah, I do that sometimes too. No. Yeah. Anyways, yeah, it's, students in class. It's like, oh yeah.
Okay.
All right, I can go back to my presentation and we'll go from there.
Okay.
Awesome. All right, so now that you've gotten a glimpse as to what T3 is all about, especially with last year's tremendous amount of effort and work put into these projects that will benefit the community during a critical time and that lava flow and all that fun stuff. Well, I wouldn't call it fun. Leave that for another time. Next slide. Next slide, sorry. All right, so overall, what you can pull from this whole T3 presentation as to what T3 is about is that we're here to provide STEM opportunities for all of you, and to give you a purpose in pursuing a STEM-related major or career. So if you're wondering whether or not you want to be if you want to major in a mathematics course or something like that, if you're unsure on whether or not you're a STEM student, I'd say give this program a try and see how far it can take you. In other words, you'll never know whether or not you're interested in engineering programming unless you give it a try. That's what I said to myself, and look at me, engineer, programmer, all that fun stuff. Yeah, so as I stated previously, this is a 3-year rigorous and intensive course that will develop your skills from an initial beginner's viewpoint all the way to capabilities and all the way to the skills and capabilities that will allow you to work in these large-scale community-based projects. And as I said, these skills that you learn during your first few years of high school will then be applied to like more real-world engineering. So when you're applying for, let's say, a scholarship or applying to a university, it'll give you a better glimpse as to what school you want to go to, as well as provide you some experience to tell people, like, hey, I did this programming project back in high school, and people would just be amazed as to how much time and effort went into you devoted into these projects. So if you want to give it a try and check out the program overall, and if you're on the fence on whether or not if you're on the fence as to whether or not you're a STEM student, I'd say give this program a try. So we have applications available for all of you to fill out. Next slide. If you are interested, we have some applications available. The deadline for these applications are next week, Monday, the 22nd of April. Submit them to your designated program coordinator. Now, does everyone know who their program coordinator is for the Upper Bound program? Do you know who to contact? Awesome, sounds good. If any of you are interested, the applications are available right here. Just come over to the front and I'll pass them out. This concludes the presentation. Thank you for your time. Yeah, we hope to see you again as part of our T3 Alliance program. Thank you.